So, good afternoon, everyone. Welcome to my presentation. I'm Zhao from Peking University, China. And today I'm going to talk about our work on applying knowledge graph to information retrieval. The title, though a bit long, actually denotes what we aim to do. That is Tailor knowledge graph for query understanding and the method. So, why do we pay attention to knowledge graph and query? Here's a background. Knowledge graph are growing fast now, and there's a new trend that they are applying. There's a new trend that they are playing a more and more important role in information retrieval. The search engines develop their own knowledge base, and entity-centric queries are taken center. Let's take the most popular queries in Google Zeitgeist as example. In early years, top queries are modeled as strings, and then from 2011, the entities start to show up, and the schemas are more enriched. So from the most popular queries, we can see that entities are playing more and more important part. So does that mean we should pay all attention to entities? Actually, the most intuitive way to apply knowledge graph to queries must be the info cards that you see in a search engine. The structured data about one entity in the window. But actually, there is a problem that a search intent is conveyed by combination of words and URLs. So the same entity with different refiners and URLs can convey different information need. So you see the 4 strings and a clicked URL about the same entity, Doha. So they look so different in the string level, although they are about the same entity. So how can we capture the relation that the top 4 are actually about the same query intent that is in the tribal domain, and the last one is different. So here's our basic idea about making intent topic nodes. So as we mentioned before, we segment each query into 3 parts: the entity words that can be directly matched in a topic in knowledge graph, and the left refiner words and the clicked URLs. We view them in a unified framework, and we see them as intent topics. The idea is that we can represent them with combination of concepts in knowledge graph. So how to generate that kind of representations? Let's first look at the Freebase schema. Actually, we here use Freebase, one of the most popular and the largest available knowledge graph now. It has more than 40 million concepts about real-world entities, and also known as topics here. They are stored as nodes in a graph, and they are linked to each other by properties. And luckily, the property has a very good structure. They are separated into 3 parts by slashes, and the first 2 actually they consist with the type of the topic that the property links to. For example, the Doha, the entity, it links, when it is in a location type, it links to the airport through the property nearby airports, and when it's in a travel destination type, it links to the museum through the tourist attraction property. So the type actually, they model the multifacet of a topic. So you see the structure is perfect for describing a search intent. So we later use the two kinds of features, the free-based topic feature and free-based domain feature, to describe the search intent of intent topics. So here is a roadmap of our method. Let's go through it step by step. First, let's see how we make the intent topic graph. As we mentioned before, we segment the query into 3 parts by relying on the state-of-art entity tagging tool. Here we use tag me, and and by aggregating the query log, we can get an intent topic graph. The edge in the graph actually encodes the explicit co-occurrence in the query log and implicit intent feature similarities. And now we can label part of the nodes with intent features. That is entity words that can be directly mapped to freebase. As there are 2 kinds of intent features. First, we link some of the intent topics with several related freebase topics, along with relevance score, which we derived by freebase API. Then we use the search sessions context to smooth the feature. That means we use the search sessions freebase domain feature to describe the intent topics domain feature. Yeah. So this is the donations and formulas. Looks a bit complex, but the idea is very simple. That you have to notice that the T and D with numbers as subscripts actually denotes the topics and domains in freebase, and that and rows in bold means the feature vector. So we see different the different kinds of intent topics have 2 kinds of intent features, and based on that, we can get the feature of the query and the session. Here, because we have different confidence for different kinds of intent topics, so we actually use a weight function to control the impact of different kinds of intent topics. We'll later show in experiments. And now we label some of the nodes. So how can we get the feature of all the intent topics we make before? Here we rely on the famous semi-supervised learning algorithm proposed by Zhang, the label propagation. That actually tells us how to utilize partly labeled data to generalize to the whole data set. But notice that here we have 2 kinds of intent features, and we use the features as the soft label of nodes. And we actually propagate the intent features in an alternating way. First, we propagate the topic feature. Here, the edge only contains the co-occurrence relation. Then as after this propagation, and the intent feature of each intent topic node is updated. So the edge So the edge can merge more about the intent similarity. Now the weight of the edge is updated. So now we can propagate the domain feature, but we cannot carry on this progress forever because the nodes, the number of nodes is very large, and there are more and more similar nodes. So to reduce the sparsity, we actually use a merge progress to integrate the intent topic nodes that have similar names and similar intent features by local sensitive hash. And this can actually form a large integration. So after several rounds, we can get a more complete description of the intent topics we model. Here's the algorithm. And now we can try to apply them in the query understanding. Actually, query understanding is a little ambiguous task. So here in experiments, we propose our new task. First, let's see the data set. For query log, we use the AOL query log, and we did do some pre-process. We stack them into query sessions or search sessions. Here we just use the simple idea of session, that a sequence of queries with a certain time interval. And then we filter out the noisy ones and the less centric ones, less entity-centric ones. So now we get the queries that we got. It's still a little large, and for Freebase, we just extract part of the data just enough to cover our query log. And even though Freebase has a lot of information about topical equivalent websites, we can say only a small part of URLs in the query log can be covered. So actually, it's meaningful to make URLs and a kind of intent topic. So in evaluation, we try to answer the two questions: intent topics helpful, and how does the different kinds of intent topics differ in effect? Here we use an evaluation task called the session intent understanding task. That is, we extract a search session from a query log, and we tag the dominant domains ourselves. That forms a test set. Then we use different methods to get the sessions domain intent feature, that the Freebase domain vector. Then we rank the domains according to the weight in the vector and compare it with what humans label. We use the following 5 methods where we control the impact of clicks and refiners by 2 parameters, lambda r and lambda c, and the metrics. Evaluation metrics, we use the rank-based one. Here we use the geometric mean average precision that is just more robust to the noise than the arithmetic one. Here's the impact of lambda r and lambda c. The bottom left corner is the method that use only the entity. We can see when we add intent topics into it, it actually helps the result. The color is darker means the result is better. And the result, actually, we can see that the best result that the darkest color occurs when with lambda c larger than lambda r, which is more obvious in the GMAP metric. Also, there's a obvious diagonal line in the MAP diagram that you can derive that a more balanced combination of, a more balanced combination of cliques and refiners can get better results. And here's a detailed results. And the line chart in precision at key. So we can see that the when we use the knowledge graph based intent topics, we actually can help the query understanding task. Also, here's the whole framework. Actually, the intent topic, you can see them as kind of linguistic unit that convey a unique information need. So to summarize, we tackle the problem of query intent understanding by representing entity words, refiners, and click URLs in a unified framework as intent topics, and we represent each intent topic with a combination of concepts in knowledge graph. And here in our experiments, we mine more about the schema of Freebase. That is, we use two kinds of intent features, topic vector and domain vector. So that's all my work. So do you have any questions?
Okay, let's first thank the speaker. You have any questions from the audience?
Hello, nice talk. I wanted to ask you that you calculated the duplicates, that you find the duplicate nodes. How did you find it? Maybe I skipped it or.
Duplicate nodes, yeah.
In the intent topic graph.
Yeah, there's a more detailed description in my paper. That is we actually use by duplicate nodes, yeah. we mean the nodes with similar names, such as what to do in Doha, what to do in, and what to do, and something like that. The similar strings, and also the intent feature vector, the similar vector, and we merge them.
Okay. And you also calculated the relevance score of intent topic with the free-based topic. So how you calculated the relevance score?
Sorry? Okay.
You calculated the relevance score?
Yeah.
Yeah, so how you calculated
Yeah,
it?
the relevance score, we actually derived that from Freebase API. Yeah. And combining like the anti-tagging score and the relevance score about a string and Freebase topic and combine them.
Okay. Thank you.
Thank you.
Any other questions? I have one. So you had the query logs.
Yeah.
And then you had human testers. right? So what were they testing? I don't see what the evaluation was.
What? Sorry?
So you had a query log, and you take a session from the query log, right?
Yeah.
And then you expand what were the human evaluators doing with the session?
Oh, yeah. The human tag the dominant domain of the session, such as tribal domain or others.
Okay, and they were comparing what they tagged with what your system would produce.
Yeah.
Okay. Okay, thank you. Any other questions? Okay, let's thank the speaker one more time.